Hello everyone, my name is Ionut Craciunescu. I am Head of Platform Engineering at Wealth Wizards, which is a fintech company based in Leamington Spa, UK, that automates financial advice for things like pensions or investments. The topic for today, as you might have noticed already, is about protecting data in S3 using access controls and encryption. I hope by now everyone knows that S3 is the greatest cloud service of them all. Following many people's vote in #Cloud Madness Quest run by Forrest Brazil from A Cloud Guru about a year ago. And as Mike Deck, AWS Solution Architect, posted on Twitter, S3 is a highly durable, scalable storage that doesn't require you to manage any hardware. Now, S3 is just great. There is nothing unsurprising that creating an S3 bucket is pretty straightforward. You can go in the AWS console, just give it a name. You can change public access settings if you want to do so, but better to leave that tick box checked. And configuring things like server-side encryption is just a breeze. Whether you want to use Amazon managed keys or your own keys is straightforward. And if you have multiple buckets that needs management, you can easily do that through templates provided by tools like CloudFormation or Terraform or Pulumi. So again, in short, S3 is super good, so just great. But data leaks from S3 is still a thing, with new entries still being added on the list. So you can ask yourself, how can I secure my files in Amazon S3 bucket? Well, you can start by creating your buckets as being private, so public access is being restricted. You can use IAM policies to allow users access to your buckets, or and allow access to applications to data in S3. You can use S3 bucket policies to configure cross-account access, or maybe restrict access to your bucket unless it meets specified criteria in the policy. There is a block public access setting on S3, which is a bucket setting or account setting or at account level, which you can use. You can also configure data encryption by ticking the box in S3 for default encryption, and you get the option to use Amazon provided key or your own keys managed by KMS. And lastly, there's the option to set ACLs on buckets and objects, although this is a thing that you don't really need to do these days. Maybe unless you have to manage things like allowing S3 log delivery, for example. And you can ask yourself, okay, among these things, what would be the best combination? How would that look like? Well, if you like Venn diagrams, it might look like this, and with a combo of S3 bucket policies, IAM permissions, KMS key policies, and being access granted by each one of these controls, then you can get access to data in S3. At an infrastructure level, it might look something similar to this diagram, which is a setup that we have adopted at Wealth Wizards. Buckets are configured to be private, and they have policies attached to them that are configured to put in place source IP restrictions or VPC endpoint restrictions. So in order to get to data in S3, you have to be on the correct network to be able to access the approved VPC endpoint, or your traffic has to originate from an approved IP address. Doing so, in essence, achieves similar access patterns to having a private storage layer in a private subnet, like my own database in a private subnet that I manage. So in this particular example, things like maybe Lambdas or EC2 instances or software running on EC2 instances that require access to S3, they have to be on the correct network, they have to be able to traverse security groups, have network access to VPC endpoint, and the endpoint they are coming from, it has to be whitelisted or allowed on the bucket policy. A similar setup, we've done it for KMS policies or KMS keys by using KMS policies, which are configured with source IP restrictions or VPC endpoint restrictions and additional filters for application to access them. Policies look similar to this one, and this is an example that allows access from IP addresses or VPC endpoint. One thing to note about this one is the effect is deny, and that is intentional because you can allow access through IAM roles, or you can allow access through S3 bucket policies. And in this case, we wanted to make sure that the network path towards S3 bucket is controlled. One thing to know that this condition is an AND. These two conditions is an AND between them, so you have to make sure it works for whatever setup you are trying to achieve. This variation, it was the first take. This is how we started with bucket policies, but after using them for a while and we've learned more about access patterns, we've learned they're not quite suitable everywhere. There might be situations where a service cannot be started inside of a VPC, and in that case, again, using an effect deny everything unless it matches a list of approved IAM roles, which have additional restrictions on them. A similar take we've done for KMS key policies, with a slight difference that for KMS you have to have a key policy which allows us, or doesn't enforce the use for what we needed to achieve. It doesn't enforce the use of effect deny, so we're able to use multiple statements with effect allow, and this is an example of allowing administrative access to a KMS key and source IP conditions for it. If you need to allow S3 to use a KMS key, then this is how it would look like. The two strings via service and encryption context, they are added automatically by Amazon when there's a request to read or write to on an S3 bucket, which is configured to use a particular KMS key. And with in there, you can add the object ARN. Now, by using this combination of storing data in S3, which is configured to use KMS keys, KMS key policies, S3 bucket policies, IAM roles with restrictions and network restrictions, it helps mitigating various risks like denying unauthenticated access, deny access from unapproved networks, prevent disclosure of data at rest. But there is still a question among us in regards to, have we got this done right? Is there anything we could have done better? Are we maintaining the same level of security compared to having data in a database that we manage, which is completely in a private subnet, and we do application level encryption? So in order to answer these questions, wordly mapping is a tool that helped us quite a lot. For those of you that do not know, wordly mapping is a tool for strategic intent, which is based on 5 steps, Sun Tzu's 5 steps. And the map looks similar to this one. You start with user needs, and in order to fulfill the needs, you require various capabilities. You draw the relations between those capabilities, and because not all of them are the same, they are placed in different stages on the evolution axis, let's say, and you can have capabilities. In this example, some of them could be custom built, others could be rented, others could be just a commodity. And an example for a business, for a company which is in the business of selling cup of teas, it would need, for example, cups to do its business. It needs teas, it needs staff, it needs hot water, and it needs kettles. And if you look on these maps, the kettles are placed, for the sake of the argument, in the custom built area. And you can ask yourself, why should we custom build our kettles? Does it make sense or not? So what I want to highlight is that wordly mapping helps with learning about your environment and learning your landscape in order to make better decisions. If you want to learn more about wordly maps, you can go to websites like learnwordlymapping.com. The way I've been introduced to them was by watching the talk titled Crossing the River by Filling the Stones, which Simon Wardley did a few years ago, and I think that's fantastic. I would highly recommend it to everyone. The way we used wordly maps at World Wizards, well, in this context, we started with the need, which is to protect customer data, and it happens for the data to be in S3. But regardless of data being in S3 or not, it can be anywhere. In order to get to data, one needs to traverse these layers. It needs network access, it needs to be authenticated, it needs to be authorized, and it needs to be able to encrypt and decrypt the data, regardless of who's accessing us in being good intent approved or a potential attacker. Going back to S3, buckets are configured to be private. They are also configured to block public ACLs, and these two coupled together, they deny unauthenticated access. Then bucket policies attached to the buckets are configured to deny unless traffic originates from approved list of IP addresses or VPC endpoints, and these two, they deny access from unapproved networks in cases where you get leaked AWS keys. TLS encryptions, for example, on the other hand, prevent disclosure of data in transit. And then once you enable KMS integration with S3, you prevent disclosure of data at rest, and can be quite detailed in the KMS key policy and whitelist only particular object ARNs, and that, for example, helps with preventing a key to be reused across different customer data for situations when you need different customer data to be encrypted with their own keys. And then you can go and highlight on this diagram what is required for S3 to access data, to make use of a KMS key. In essence, to be whitelist or allowed access on the KMS key policy setting. And obviously, it's not just about S3 itself. Administrators, they need access to S3 too. So you can have an IAM policy, an IAM role that admins assume with a policy that allow access to S3. But that on its own is not enough. You also need access to the KMS key. If you have access to S3 but not to the key itself, you will get access denied. So you need access to both. To complete this diagram, it would look like this. And you can see, okay, the KMS key policy in there is used to allow admin access. And probably I should have had a connection between allow admin access and allow IAM role. That's a thing I can improve on this diagram. But in essence, the key policy is quite restrictive and has a setting saying you can use this key if traffic originates from this particular IAM role and has IP restrictions on it as well. And in order to assume the IAM role, it requires SSO login using my identity provider of choice. Then I need to be logged in with a username and password, which has an MFA on it, and that prevents leaked credential reuse. Obviously, once again, it's not just about S3 or admins, it's about applications, because that's the important thing. Without applications being able to get to data, all of these wouldn't be very useful. So apps have IAM roles that they assume with policies that gives them access to S3 and also to KMS. And here you can play a bit. So you have to use KMS keys, as in KMS key policies, but there's the option to be quite open in the key policy and choose to rely on IAM policy and roles to give access to KMS. But then if you ask yourself who or what has access to my KMS key, to my data encryption keys in essence, you have to look in various places, and answering this question becomes quite difficult. To improve on that, it's better to be more restrictive or to be quite restrictive on the KMS key policy and allow, for example, access to the key only if traffic or request originates from a particular role. So that helps with having to look in a single place if you want to know what or who has access to a particular KMS key. You can also notice, okay, I have KMS key policies that allow access to a bunch of IAM roles, but those roles, they also have policies that give access to KMS. So the IAM policy used by the app, you can be quite open with that and say, for example, allow KMS anything. And the key policy is the control that you put in place. And you can also argue that there might be a bit of duplication between these two. So you can remove the IAM setting that allows access apps to the KMS key. So by going through this process, we're able to identify or to clearly visualize and understand the risks that we are mitigating, the protective measures that we put in place, and how these correlate to each other. And we've done a similar process for when we store data in a database that we control, in a private subnet that we control, and when we do application level encryption. But we found out that in essence, it's mitigating the same type of risks, and the major difference is in the way they are being mitigated, as the nature of S3 and self-managed database is slightly different. But in essence, it's the same level of security. If not, when using S3 with KMS, it's even better, and we'll see about that just in a few moments. So what are some of the benefits of using this whole scenario? Before deciding to put data in S3, when we have it in our own managed databases, we're doing self-managed application level encryption. Obviously, we didn't write our own application algorithm. We made use of already existing libraries, but still there is a bunch of code in the application that deals with encryption and is not specific to our application. There's quite a lot, if you ask me, of undifferentiating heavy lifting. So why deal with that when the cloud provider can do it better than we do? And then questions like, okay, is it AES 256 encrypted, or what algorithm is it being used? Well, I don't know. Is it correctly configured? It's not quite our area of expertise because it's not directly relating to giving financial advice. Those things are better managed and solved, or these problems are better solved by the cloud provider. So by moving to S3 and KMS combo, in short, we move the application, the encryption engine from the application into the platform, achieving in essence encryption as a service, all serverless. It scales for us, which is super great. Another major benefit is being able to test access controls very easily by additional integration with AWS config. In fairness, this isn't something that we've rolled out across the board. We've done a POC, we've understood what we need to do next to make extensive use everywhere of this service. But in essence, we've designed our test, we've approached the test from a BDD perspective, and AWS config is set up to monitor configuration changes on the S3 buckets. As these are detected, it will invoke a Lambda function. The Lambda function, it will try to get access to data in S3, and whether it is able to get access to data or not, it will report back to AWS config with an output. And then based on that and the test being run, AWS config will report either compliant or non-compliant status for S3. So we are also able to get a compliance status report for our storage layer, which is super beneficial. And not only that, but also being able to test access controls. And in addition, we can become proactive. So if we have a test that fails and a function which is able to retrieve data from an S3 bucket when it shouldn't have been able to do so, then we can trigger there's a possibility to trigger another process to maybe revert the bucket configuration to its original state, to the desired state, or maybe do changes to restrict access altogether. It all depends on what you are trying to achieve. So this opens the door to an additional level of testing that we were not able to do before, or it would have been very hard and again not specific to the goals that our business is trying to achieve. And all of these serverless managed services, they're great. It's working really well. With this, my presentation comes to an end. There's more information on AWS blogs if you want to read about KMS and key policies or bucket policies. If you are interested in learning more about or finding out more about Simon-Wardley mappings, I highly recommend his talk, Crossing the River by Filling the Stones. Is super good. Now, I'm super curious to find out from you if you think these things can be improved or if there's anything that we missed. So please do let me know in our Q&A session next week. Looking forward to speak with you. Thanks for listening. Bye bye.